Hello everyone, this is Kalpana, Assistant Professor from Department of Chemical Engineering, Hindustan College of Engineering and Technology. This slide will talk about petroleum reservoir engineering. It is a vast topic. From that, we are going to discuss about drilling fluids and work completion. So first of all, we must know the requirements of a drilling fluid. So in order to drill, a lubricant is very much needed. So it will seal the rocks to prevent loss of fluid. It will prevent the flow of oil and gas while drilling, and it will lubricate the drill string, prevent hole collapse. Then it will also prevent rock dispersion. Then it will remove all the drill cuttings outside the hole. Then it will also avoid damage to the production zone. Then we have two types of drilling fluids, water-based and oil-based mud. So one is completely based on water and another one is completely based on. So in order to select which mud is best suited, a mud engineer is allotted. So drilling fluids are becoming so specialized. Most companies now have a mud engineer on duty at all times to keep the mud in good condition. It is responsible for testing the mud and for prescribing mud treatments in order to keep mud weight, properties, and chemistry within recommended limits. It must give detailed recommendations in order to optimize the achievements of technical and economical drilling aims. So mud engineer should ensure that the selected mud should remove the drill cutting from the wellbore, it control formation pressure, maintain wellbore stability until casing can be run and cemented. So it is the last step. Then cool and lubricate drill string and bit, transmit hydraulic power to the bit, and it should not hamper formation evaluation techniques. Uh, it causes adverse effects on the formation being penetrated, that is formation damage should be avoided. Then it should not cause corrosion of the tubules which is inserted inside the drill. Then it should remove drill cuttings from the wellbore. So one of the main factors is viscosity. So viscosity and fluid rheological properties have a determinant effect on well cleaning. Cuttings settle rapidly in low viscosity fluids such as water, and as a result their removal is very much difficult. Generally higher viscosity fluids are required to improve cuttings transport capacity. Viscosity is dependent on concentration, quality and dispersion of the suspended solids in the mud. So viscosity plays a very much major role in the selection of mud. Then particle suspension. So drilling fluid must also keep drill cuttings in suspension when the mud is not being circulated. The property that keeps particles in suspension is called gel strength. So gel strength of the mud is the first and foremost basic property. Then gel strength required to hold the cuttings in suspension should be no more than required. However, when circulation resumes, the fluid must be fluid enough to release the particles at the surface. So cuttings that settle when circulation has stopped can cause bridges that result in struck string. Next is thixotropic property. So this property, which is exhibited by certain gels of becoming fluid when stirred or shaken and returning to the semi-solid state upon standing. So most drilling fluids are thixotropic. This means that they undergo a gelification process in static conditions. So the mud should always be in a circulating motion. So this process allows the drilling fluid to keep cutting in suspension during pipe connections and other time when the mud is not moving. Shear thinning fluids with high viscosity are the most effective for well cleaning at low annular velocity. Next property is density. So density has a positive effect on removing drill cuttings. So higher the density of the mud, more the buoyancy. More buoyancy means greater carrying capacity to prevent the cutting from falling through the mud and to lift them to the surface. High density fluids can clean the hole very well with low annular velocity. So high density fluids are the best suited for lubricating. However, a mud heavier than necessary to balance the formation pressure has a negative impact on drilling operation. So, weighting up the fluid just to remove cuttings must be avoided. Control formation pressure density. It should also be in control. One of the main functions of drilling fluid is to keep the formation pressure under control. The pressure which is exerted by the mud column in static condition is called hydrostatic pressure. So it is the product of mud weight and the true vertical depth of the well. If the hydrostatic pressure of the column of drilling mud is equal to or higher than that of the formation pressure, then the formation fluids cannot flow into the wellbore. So it should be managed. Then we have to maintain the wellbore stability. First property is caving. So wellbore stability is a function of mechanical, physical and chemical characteristics. Overhangs, ledges and vertically dipping formations may break off and fall into the hole if a high differential, that is the high differential may be in terms of pressure or density, which exists between the formation and the drilling fluid. So swelling clays and heaving shales decrease drilling rate and increase the possibility of struck pipe and fishing jobs. So the cement job is a determining factor to effective isolation between the formations and to guarantee a reliable completion. So it is the last step which separates the drilling fluid and also the formation. The mud must maintain the condition of the hole so the casing can be run and cemented without causing completion problems. So when running casing, the mud must be fluid and at the same time it must minimize the annular pressure losses in order to avoid loss of circulation which is caused by induced fractures. So main causes of formation damages: mud or drilling solids that invade deep into the matrix of the formation, they permanently obstructing its porosity and permeability, swelling shales which reduce permeability. So precipitation of the solids that result from the reaction between the mud filtrate and the formation and completion fluids which limit permeability. And also emulsions formed by contact between the mud filtrate and the formation fluids which also tends to limit permeability. So seal off permeable, porous and fractured forms. So permeability is a measure of capacity of a porous media to allow the fluid to flow through it. When the pressure of the mud column is greater than that of the formation pressure, liquid and solid components of the mud invade the formation and form a filter cake against the borehole wall. In highly porous and permeable formations, mud can be easily invade the formation. So the last factor is to control corrosion. Because the drill string and casing are constantly in contact with the drilling fluid and well fluids, they are constantly subjected to corrosion. So in order to avoid that, we have to use oxygen scavengers, scale inhibitors, ionite sponge, zinc oxide, and the easiest to maintain high pH. So most solutions only slow the corrosion down, none can solve it. So we have to select the proper solution. So in a drilling fluid system, the mud properties must keep the essential functions and at the same time it should minimize the problems in the well. So these are the selection which regarding the type of mud. So well design, anticipated formation pressure and rock mechanics, formation chemistry, the need to limit damage to the production formation, temperature, environmental regulation, logistics, and finally economy. So, while seeing the difference between mud properties and functions, the characteristics of a mud can influence its function. Example, the formation pressure is checked by hydrostatic pressure. The hydrostatic pressure is modified by the density or specific weight. As the uncontrolled density increases, the pressure drop increases. The consequence is possible loss of circulation. So fluid engineer always need an exchange of condition to treat and keep optimum drilling conditions. For instance, an out of proportion viscosity increasing improves the hole cleaning. So the loss of pressure increases, the capacity of removing solid in the mud decreases, penetrating rate slows down, and the dilution treating increases. Also, the preparation with consequent cost